you all are doing well today. And if you have been given access to this video, it means on your 2 attempts from the periodic table quest, you did not achieve a passing score. So what I'm going to do for you is very briefly give you a crash course on the periodic table so that you can have success on the quest that you must pass in order to access the next folder in the Woo 2. So what I want you to understand is that every piece of material that we've given you in this periodic table folder covers a question on the quest. I even double checked, I even went back, I watched the videos again, and I even caught things that I didn't catch the first time, and I went through, like, let's say, what you can consider your online text material. I went through that again, and I caught things that I didn't catch the first time. So maybe a piece of advice that I could give you is write down a little bit of notes. I'm not asking you to take 10 pages of notes. I'm asking you to maybe take a page of notes in the entire folder so that you can kind of do repetitious studying and you can understand the main points of what we're trying to get to you in these little subfolders. So let me do this though. First, I want to show you, I don't think that you all are utilizing ptable.com to its fullest potential. So if you see here, just so you know, the periodic table, if you look, like I have a 1 from left to right, 2, 3, 4, 5. So the periodic table from left to right and then top to bottom is going in chronological increasing number order based on the atomic number. So I'm going to say that again. The periodic table is arranged based on the atomic number of a specific element. And that the reason why it's done that way is because specific families are all going to behave alike, and they have the same trends happening going across the periodic table, whether it's vertical trends or horizontal trends. And then something else I like too, you can actually literally hover over every single topic and it highlights for you the periodic table where they're located. Like the noble gases, remember, their outer electron shell, their valence shell, is completely full. So they're happy, they're content, they're fat. They're like a king. He doesn't need anything. There's no wants or needs. That's why it's called a noble gas. They're inert. They won't react with everything. So that's the description of the noble gas. You don't know that. So guess what you can do? Click on it, and it actually brings you right to Wikipedia and helps explain a little bit in detail. You don't need to know all this, but explains properties that the noble gases have. So you'll really like this. You need to know they're odorless, colorless gases, and the chemical reactivity, which means they don't react with other elements. They're happy, they're fat, they're content. So you can do that for every single, do you see family that you see here, the vertical families? And again, they all behave the same way. That's why I like to call them a family. It's because it's your family. You guys all act alike, if that makes sense. So I just wanted to show you that. Utilize too the fact that the P table actually hovers for you at room temperature what elements are solids, which ones are liquids, which ones are gases, and this will be beneficial to you also while you're going through your periodic table quest. Okay, this is something that will help you too. This is something that was straight basic concept of the periodic table. You're going to have, just so you know, you're going to have something called groups and periods. And again, they're organized vertically this way. So 1, 2, 3, 4, 5, 6, all the way to 18. These guys all behave trend-wise similar with who they are residing with on the vertical line. And then in periods, there's other trends too that these elements behave like because they're all in the same, let's say, 5 row, if that makes sense. But this is taken straight from your OHS. So try to find that again. It's in the first couple pages, and it helps explain to you a little bit of how to read trends on the periodic table. The 4 trends that you're probably going to need to understand is, in some fashion, atomic size has a flow on the chart. Ionic size has a flow on the chart. The ionization energy has a flow on the chart. And then electronegativity has a flow on the chart. So what am I talking about when I say that? So let me show you. I found this. I love it. Okay. So all you need to know for, let's say, when we're talking about atomic radius, is that the atomic radius from top to bottom is going to get larger, and then from right to left it's going to get larger. So atomic radius of an element. So guess who's probably going to have a really big atomic radius? It's going to be this element right here in that box. So from top down, right to left, atomic radius size increases. Okay? Ionization energy increases from left to right, from bottom to top. So what that really means is this row right here, and I'm actually not talking about the noble gases, this guy right here is highly, highly reactive. He's going to want to try to steal an electron from just about anybody he can, and he's probably going to want to hook up with someone in this vertical group right there. Okay, so electron affinity, if you want to know, is kind of the same thing, meaning from left to right and then from bottom to top, the electron affinity increases also, meaning it's very, very, very reactive. So a low reactivity is probably going to be somewhere in the middle, or let's say right here, and that's where we really want to find, where we want to start doing covalent bonds instead of stealing electrons or donating electrons and creating an ionic bond. You are probably going to have to be able to associate that here, majority of the elements are going to be metals. You need to figure, and metals, by the way, are in blue on this chart. You need to understand that metalloids, which means they have properties of metals, and nonmetals are the pink. It's like that stair step on the periodic table. It's right there. And then nonmetals are the ones, including hydrogen, that are colored yellow. Okay, so if you kind of look, metals encompass majority of the elements found on the periodic table. And you need to know characteristics of metals. You need to know that metals tend to be shiny in appearance, malleable, and ductile. So what that means is you can kind of bend them in the shape you want them to go in, and they're not going to like shatter on you. You can beat them into a flat sheet, and they're great conductors of heat and electricity. So that's why all wire, the fact that we can form it into like a copper wire, and electrons really, really, really like navigating on metals. So they're great conductors of heat and electricity. We can do what we want to them in forms of shape, and they're usually shiny in appearance. You need to know about nonmetals, okay? They tend to be dull in appearance. They don't really conduct heat or electricity well at all. Brittle, which means they break easily, so I can't beat them into the shape that I want them to be in. And they tend to have a very low density, meaning how many molecules are squished in a given area. And they tend to have a low melting point. Hopefully that helped you a little bit in order to have success on the periodic table quest. What I would suggest to you is watch those 2 videos that we have in there, especially the crash course on the periodic table. That was done very well. Start about 5 minutes, go from about 5 minutes to 7.5 minutes. So all I'm really asking you to do is concentrate on a 2.5 minute clip of that, because that has a lot of information on it that you will need. Good luck!